Hello, everyone. Good morning. I hope you're all well. Personally, I'm feeling a little rough after last night, but okay enough to do this. Let's go. Just a little bit about myself. My name is Pauline. I'm a freelance software engineer on paper, but kind of employed in the aviation industry right now, which is very different. I'm not writing PHP anymore, but it's also very fun and exciting. I usually talk about Git, just like this time. Has anyone ever seen any of my Git talks? Okay, a few hands. Okay, there's going to be, for you, specifically if you've seen the one that I didn't do here last year, but I think the year prior or somewhere else. Specifically, if you've seen the advanced Git talk, there might be a bit of repetition for you. But I think that's probably good for Bisect. I'm also an Amsterdam PHP organizer, so the user group in Amsterdam. I'm a mother of a 3-year-old child. I play American football, so when you see football, it's American football. And I knit, and I like to learn about electronics, so those are my hobbies. I am on Twitter, despite it being kind of a shithole now. I'm also on the PHP social server for on Mastodon, if that's your jam, although I'm not as active there. Depending on what's happening on Twitter, what scandals are happening at any given point. So let's get to the business of this talk, which is the business of bisecting. So I saw some of you did see one of my Git talks before. Have any of you used bisect before? Okay, much less hands, much fewer hands. That makes me very happy. So this talk is going to be, like I said, there's going to be a little bit of repetition from my other Git talks where I kind of lay it out I lay out kind of a basic version of what I'm going to talk about here. The reason I wanted to do a bisect specific talk is that bisect is really one of my favorite, if not my favorite Git feature. It's really, really great, and it's kind of a mythical beast that a lot of people don't know about or have heard about but never use because they're not sure what it is. And I think it's really kind of magical. So I wanted to do kind of a deep dive where normally I'm kind of showing the basics. I want to go a little bit more niche. So I hope you'll like it. This is the first time I'm doing such a deep dive into bisect. But before I continue, I wanted to just quickly point you towards this repo. You can follow along later if you want. I don't see a lot of laptops out, so I don't think people are probably going to follow along. You can if you want to, but if not, still save it because this is kind of a play repo where you can play around with bisect. In your own time, and it has like a README with all the instructions, and you can follow along step by step what we do later on in the talk. It would help a lot if you have Docker Compose, because the PHP version is a little dated, so if you try to run it with PHP, you might run into issues. But there's some pretty convenient make commands and stuff for you there that automatically spin up the container and run everything, so it should be pretty easy. Okay, now, bisect. So, okay, a few of you have used bisect, but how many of you have heard of bisect before? Okay, so yeah, so this is really, really good actually, because like I said, a lot of people know about bisect, but have never really used it, and I want to remedy that. So bisect, I usually, if you've seen my talks before, you'll know this analogy, because I usually use an analogy of an egg and a building to explain bisect. So let's say someone gives you a bunch of eggs and points at a building and says, these eggs are magic eggs. They don't break very easily. And I want you to go to that building and drop an egg off the building and find me the first floor where you drop off the egg and it breaks. So what you could do is you could start on the ground floor, drop the egg, it doesn't break, you pick it up, you walk up the stairs to the next floor, you drop it there, it doesn't break, and you just keep iterating and iterating until you find the first floor where your egg breaks. So potentially, This could take really, really long, because you have to walk down the stairs, pick up the egg, go upstairs again. And if this building is really, really tall, and these eggs are really, really sturdy, it's going to take you many, many, many iterations to find that first floor. So you can also start in the middle. So you go to the middle floor on the building, and you drop the egg, and it doesn't break. So then that tells you that the first floor that the egg is going to break is between there and the very top floor of the building. So you walk to the middle point between those, and there you can tell, oh, okay, I dropped it and it breaks. So then you can tell that the first point is going to be in the middle of those points. So you keep going in the middle of the points that you've tested, essentially, and then you'll find, statistically, you'll find your the point that you're looking for much quicker than if you were to go step by step by step. So this is exactly the method that Bisect uses to find a specific point in time in your repo. So let's say, especially regressions are so if you found a regression in your project, some sort of unexpected behavior on production or whatever, you can find the commit that introduced that regression really easily using Bisect. So let's say this is your beautiful homepage, and you have this nice header image, and you notice that somewhere along the line, this header image has moved down. And you want to figure out where that happened. So one approach that many people will probably intuitively take is to look at their commit history and try to deduce from the messages what may have introduced this. So you might look at like some styling commit or like a JavaScript thing or something that may have affected this. And then you might check that commit out, or you might, diff it to see if that was the culprit. And in my experience, sorry for the coughs. In my experience, that's kind of like that, taking the building floor by floor. Usually you think you'll find the point really quickly, but you don't. So Bisect is a really good contender for this type of situation. And this is kind of a basic use of Bisect. So you start your Bisect by get bisect start, and then you mark a commit as good. That can either be by the commit hash or a commit ID, or even the head tilde number of commits you want to go back to, if you're familiar with that one. If not, you'll see it in a second. But so you mark a specific point in time as good, and then you mark usually your head. So the default is your head, so your current commit is bad. So you can say get bisect bad another commit hash to look between two specific commits, and that's your bisect range, or you can just not pass anything, and then it'll take your head, which is usually the case. Then you refresh the page, and then you see, this commit, because bisect is doing that thing where it checks out the middle commit between the range you've given, just like in the building. So it checks out that commit, you refresh the page, and then you see, okay, the header image is good here. So I'm going to say get bisect good, and once you've marked that one as good, it's going to check out the middle between the range that's left, and then you kind of just keep testing like that. Get bisect bad, so here it was moved down. You go get bisect bad, next one, get bisect bad, and then eventually it'll say something like, so this is kind of the simplified output. We're going to run it for real in a second, just so you don't get overwhelmed when we demo, because there's a lot more output than this actually says. But at some point, it's going to tell you blah, blah, blah is the first bad commit. And then to get out of your bisect, you go get bisect reset, and it'll just take you back to your head, and you're done. So I'm just going to show you what that looks like. I think I still need to, yeah. Okay. Let's see where yeah. Okay. Okay, so get bisect start, get bisect. I'm actually going to use different terms now. So bisect actually offers the good and the bad term, but it also offers old and new. So you don't necessarily have to be looking for good or bad. You could also be looking for something else. So it offers you kind of two default terms that you can use. So I'm going to say git bisect old was head tilde 20. So this is my 20th commit from now, like back in time. That's the notation I was referencing before. And then git bisect bad, not bad, new. So it does exactly the same as the good and the bad, but it just kind of helps you, the terms kind of help you make sense of what you're doing. So you're just going to mark that like that, and then you just keep going. And you'll see that this output here, it shows you kind of how many revisions you still have left to test in that range, and roughly how many steps is going to take you. So the roughly kind of depends on how you mark the commits. That might change the kind of the amount of steps that it expects to take. So here at this point it says roughly 0 steps, and then so I'm going to mark the last one is new, and then this is the full output. So you'll see blah 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 is the first new commit, and yeah, the term is the one that you gave it, and it'll show you the full log output. So like author, a commit message, and kind of a summarized version of the diff. So that's basically it, and then we reset it. So that is bisect in its most basic form. Any questions so far? Feel free, we're in a small room, so feel free to put your hand up if you ever want to ask a question. Okay, so all clear so far. Great. Now, like I said before, you can bisect for anything. Most commonly, you'll probably be bisecting for regressions, but you'll find as you start using it more and more, you'll find that there's many use cases for bisect, and not just regressions. For instance, let's say you're working with like a compiled language, and you've noticed that build times have suddenly started becoming really long, or like your test suite has suddenly started becoming really, really slow, and you want to figure out why that is. You can do that too, and so we had the old and the new and the good and the bad terms before, but you can also give it your own terms. So if you start it with term old, so it uses this term old is kind of the new and the old is what the flags use. So term old, and I'm going to say fast, because the test suite used to be very fast, and then term new, now it's really slow. And you'll notice also, if you've forgotten which terms you've used, you can just git bisect terms, and it will show you the terms. And also, if you now attempt to use another term, it'll also tell you that you're doing a slow, fast bisect. So again, it does exactly the same thing as with the old and the new and the good and the bad, but it can just help you kind of not get information overload from like complicated bisect plus weird terms where you're not sure what they mean. Okay. So, yeah, okay, I already showed you now. I forgot I had a slide. Yeah, so these are the flags if you want to give it your own terms. I do feel like those terms, they're quite handy if you're not super comfortable with bisect yet and you're checking for other things. I think at some point you get so used to what bisect is doing that that it doesn't kind of screw with your head anymore to just use good and bad. Go ahead.
Reset. When you say git bisect reset, do the terms then go back to old and new, and good and bad?
Yeah. So just to reiterate the question for any people watching online. The question was, if you git bisect reset, do the terms then reset? And the answer is yes. So any bisect that you start, you can start it with those flags, and just for that bisect run, it's going to use those terms. Okay, so let's say you have, so in the demos that we've gone through so far, they've been pretty short, but you'll probably have a few cases where you're going through a lot of commits, and so you have a lot more steps. So let's say you've gone through like 30 steps. And then you've noticed that you actually marked a commit as bad when it was good. One option would be to git bisect reset and start all over again. But I mean, if you've already done 30 steps, that's kind of annoying. So I want to show you something pretty cool, I think, that a lot of people don't know about. So again, this is going to be a very short demo, but just imagine I'm going through like 300 commits. Oh, oops, I've given the wrong, let me just start over. I want to mark that one as good, and this one is bad. Okay, so let's just do a couple of steps. Good, another good, and let's go with another bad. Okay, let's say this last one, this last bad was incorrect, and I should have marked it good. And also, let's say that there were more than the 3 steps that I just showed. So what you can do now is, if you git bisect log, it'll show you a log of all the commits you've marked so far. And if you then write that log to a file, so let me show you. So it's there. Then you can git bisect replay. Oh, almost. You can replay your log. Well, actually, I should have said you can edit your log file first, because now I'm just replaying the same log. So I'm going to go in there, and I'm going to just remove this last one, which I'll just do both those lines. And then when I replay it, it will have not replayed that last one that I removed, and I can just mark it as good. There you go. So that can be really handy, specifically when you're bisecting your main branch for something very, very far in the past. If you have to go through like 300 commits or something, and you're doing that manually. Ooh, I just gave you a little spoiler. Because you don't necessarily have to do it manually, which we'll get to in a second. But yeah, if you're doing that manually and you're going through many, many revisions, then it's pretty common to mark something wrong, and it can be a real lifesaver. I think there was a question.
Start command reset, or is it the replay that does the reset?
It's the, wait.
You had a bisect in progress, then you ran a replay. It seems to ignore the fact that you had another one in progress. Like, was that the start of that, or was it the replay?
It replays the one it just replays the one that that's active, basically. But you can also start a new one and then replay from scratch, basically. So you can do it while you're still in your bisect. You don't have to get out of it with git bisect reset. You don't have to, but you can start a new bisect, or you can do it in the one that you're active in now. Oh, sorry, I forgot to relay the question to the audience. The question was, God, how did you phrase it again? Well, I suppose it was in my answer already. So the question was, do you have to get out of the bisect to properly replay this log file, or will it interfere with the one that you're bisecting now? And the answer is it doesn't. It really just replays all the steps, and whether you're in an active one or not. Okay. So I already gave you kind of a spoiler, but you can automate bisect, and that's where it gets really, really, really interesting, I think. Did you have a question? Sorry. Oh, okay. So so instead of marking every commit good or bad manually, you can feed bisect a script. So very often this is like a bash script, something simple, or something not simple. Depends what you feel like, I guess. But the idea is that if this script exits with exit code 0, it will mark the commit as good automatically. And if it's, off the top of my head, anything between 1 and 127, so basically any other exit code almost, then it'll mark it as bad. There is one extra special exit code that we'll get to a little bit later in that range. Yeah, generally you usually want to like exit with either 0 or 1 or for good or bad. So I've written the script here because if we look at this repo here, it's missing something that most repos have. Can anyone spot it? README, yeah, I heard a very soft README mumble. It is indeed missing a README file. No, I don't want to bisect yet. I just want to double check that at some point it was there. So I'll just take like a random point in the history of my repo, and I'll see that 25 commits ago the README was still there. So now I have a point in time that was good, and a point in time that was not good. So let me just go back to my head. And like I said, I have this readme exists script that really just checks for the file, and then if it exists, it's going to mark it as good. It's going to exit with 0. And if it's not missing, it's going to say nope, and it's going to mark it as bad. Now, I've put this, can anyone actually guess why I've put this script outside of my repo? Exactly, yeah, so exactly. Because you're essentially time traveling, and your script exists now, but not necessarily in the past. So the easiest thing to do is to put the script outside of your repo, so you can comfortably check out commits without it affecting anything. So let's get my sync to start. Good, head tilde 25. And bad is now. So instead of starting to mark everything, so that was still manual, but instead of starting to mark everything good or bad manually now, I can git bisect run and give it my script. And this will be over in like a flash, obviously, because it's not many iterations and it's automated. But you'll see the output. Let me just try and scroll up here. So you'll see a few iterations here. File exists, nope, file exists, blah, blah, blah. So you see the exact same output as if you were doing it manually, but it's just marking everything automatically. And then it says here, blah, 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 is the first bad commit, and it's this fixed join screen styling. So let me just clear this for clarity. So let's just get out here. And then we're going to go look at this fixed join style. Was it this one? Yeah. So just to double check, we're going to say, I think it's name status, between this commit right before it and this one. And you'll see that indeed, like the CSS file was modified, but also this README was deleted. So then you can really easily kind of see what happened. This is a really simple example, obviously, where it's just a missing file. So it's not a huge deal because you can just get the file back and put it in your head now. But if it's a bug, this can be really, really useful, especially if you don't have the best test suite, for instance. Tests, well, we'll get back to that in a second, actually. But tests also work with these exit codes. So it'll have an exit code of 0 if the test passes and non-0 if it doesn't. So you can also use tests to find bugs. So that's even better. So especially, like I said, if you don't have a great CI/CD pipeline, or if you don't have full test coverage, which I'm sure all of you do, but if you don't, then you might have some unexpected behavior. Or, like I said with the CI/CD pipeline thing, if you let people merge things into your main branch without all the tests passing, you might get into situations where, at some point, obviously when you write the test and you commit it and you merge it, when you wrote it, it probably passed, but somewhere down the line, it stopped passing. And then you can really quickly find the point in time if you run this test in the same way that we just ran the script that broke the test. which is super useful if you do want to move to a pipeline where everything has to pass, because then you have the situation where maybe a third of your tests don't pass, and they all have to become green before you can start doing proper CI/CD. So then you can take each test and just really easily find out how to fix them. So that can be super useful. Does everyone already have CI/CD pipelines on all of their projects? Okay. Well, if not, it would have been really useful. Okay, so something much cooler I think you can do with tests, we will be doing with this repo. So again, you can follow along, but it might be a little fast or confusing. So if you don't want to, you can always do it again in your own time and repeat it many, many times. So, okay. Let's go to this repo. What branch am I on? Okay, no branch. Okay, so this project is a little script to do with Trogdor. Has anyone ever heard of Trogdor? Is that a reference that? Okay, that's one nod. Okay, this is really ye old internet. This is a Homestar Runner reference. But in any case, so Trogdor was kind of a dragon man, sort of. He's a character, and he goes around medieval villages and burns cottages. So this is a script that is Trogdor. So let's spin up the container. Yep. Okay. So this is what I meant with, like, if you have Docker and Docker Compose, it makes it really easy because there's just a bunch of make commands that you can run. So I spun up the container, and then I'm going to make run, and you'll see some output. So this is the expected output, I'm afraid. So let's just see where we're, let's try to make it a little smaller. That's still readable for you guys, right? Like, I mean, it's not a big room. Let's do that again. Okay, so you'll see here that we're on our main branch, and we have a commit where everything works as expected, and it's the let it burn commit. Now, let's say I'm actually going to check out a branch called sometime in the future, but just imagine that it's not a branch called sometime in the future. It's just the same branch sometime in the future. Okay? So you'll see here that there's a few more commits since this let it burn one. And now if I run, it doesn't give me any output, which is unexpected behavior, right? So we now have unexpected behavior in Trogdor production. And we didn't have good test coverage. So what I can now do is I can write a regression test, which I've done. Let's see where it's at. I think it's in here. Oh, I want to cut this. So it's a pretty rudimentary. It's not the most robust, okay, but it at least checks if there's output that says burnination completed, and then if that's the case, then we trust that it's actually happened. So now, because this didn't work, right? This test should not be passing. Let's just double check. Yeah, so it's failed because there's no output, right? But before, here, we would expect this test to pass. Now, quick callback to that README script being outside of the repo. Can anyone see a problem with running this test, even though we know that, it should pass here, but, it doesn't exist there. It exists now and not back then. So what we can do, actually, what do you think we can do? Does anyone know what we can do here? You have to be a little, think outside the box a little bit, and you have to be familiar with interactive rebase. Are people doing interactive rebases at all? Okay, yeah, a few more. So So if you do an interactive rebase over your own branch, like so, let me just make that bigger again. So the -I makes it interactive. And we're going to rebase over the last 15, there's a 5 dangling there, the last 15 commits. And this is what that looks like. So an interactive rebase is kind of like a rebase. If you don't know what a rebase is, a rebase kind of, in short, very, very summarized, it replays your commits. And so an interactive rebase replays your commits with a little bit, it gives you more control as to how to play those commits. So we're not going to go super into that. If you do want to go into that, talk to me after, or maybe watch a recording from last year. But you can actually, with this interactive rebase, you can kind of rewrite history. So I can cut this test commit line and just move it to the past magically. So I'll move it to the point in time where I know it's going to pass. Save that. So now I've rebased it, and just to double check, this test is now there, this test commit. Can't remember how many commits that was. So let's just double check by checking out that test commit, that if we run it in the past, it will pass. Okay, so this is here, it passes. So now we have a good point and a bad point, right? I'm gonna go back to my head and start the bisect. So we have a good point, that's this commit, and we have a bad point that is our head now. And then, just like before, we're going to say git bisect run, make test, and it's going to do all the tests, and then it shows you the commit immediately. And then we can see kind of the diff here, like what happened. So the commit was, or maybe he was just a dragon, I think. Wait, was it? Okay, good. I was like, now I have to run the bisect again. Luckily, it's lightning fast. But we're just going to check the diff between here and here. Yeah, okay, so you'll see here, you know, we used to initialize him as a dragon man, and now we're initializing him as a dragon, but we're checking for dragon man, which is incorrect. So now we can really easily, I'm going to interactively rebase again. I'm just going to put this test here, why not? And I'm going to edit it. This is how you edit commits in interactive rebase. So that's just going to check it out, and now if I run my test, we would expect it to fail, right? But here we can just fix the check that we broke. So here we'll just check for dragub. And now I would expect it to, okay. So there we go, add that to the commit. So our fix is now in that test commit. So now we've made a regression test. We've let that test debug it for us. We've fixed the bug. And it's all in a neat little commit that we can just put back in the future. And we'll just amend this commit message to say fix burn a nation or whatever. and that's that. And then you can create a PR, and it just makes your life a lot easier.
There's still a rewritten history of it. Then you have like 15 commits with different hashes.
Has it rewritten history like now?
Yeah, if you did multiple replays, presumably change all the hashes.
Yeah, okay, but then it didn't because I put the test commit back. So the test. What's that? Yeah, I mean, I'm like 99% sure they do because the hashes are all based on the diff. So if the diff doesn't change, then the hash is not going to change either. Yeah, either way, you can sometimes change the hashes, and then you have to force push if you interactively rebase and stuff, which is all fine, which is all something that is covered in the other talk. I could talk about this for, well, I mean, we do have a lot of time, but I could talk about this for a very, very long time. So if you want to, come see me, and then we can talk about it for a very long time. Okay, so this example that we just looked at, it was one single test, right? It was a very small commit. So that keeps the scope quite small. And in general, I would say that covers most of your use cases. And I would also advise you to try and keep this scope small. Sometimes you might not be able to, though. But the reason I advise you to keep the scope small is that, for instance, if you're running your entire suite, or if you're going back in time to a point where, for instance, dependencies have changed between then and now, and you might have to run Composer or something like that. It just kind of complicates your life a little bit. So if you don't have to do that, I would say keep the scope small, because then, bisect usage can be fairly basic. But that being said, sometimes you will have moments where you can't really keep the scope small. Either you have to run your entire test suite, run maybe integration tests, spin up containers and things. And there are solutions to these problems. So, okay, one solution to these problems is git bisect skip. So this is a manual if you're doing manual bisect. If you land on a commit that isn't really testable because the build is broken or for whatever reason, you can tell bisect to skip that commit, and it will just check out kind of the adjacent commit. There is one caveat there, and then so you can check out the adjacent commit and see if that one is testable. If it's not, you can skip again. But if it is, then you can just keep going. But there is one caveat to this, and that is if either the commit that you skipped or the adjacent commit are the culprits that you're looking for, then bisect will not be able to tell you if it was one or the other. Because you skipped one, and so the kind of the binary search that you're doing is ruined. But it's going to be one of those two then. So then you would have to kind of manually check both of them out and just see for yourself. You can also, I will just show this here. In fact, I'm going back to this other repo that's a little bit simpler. So git bisect the start. Now let's say I'm starting my bisect here, and let's say that I'm running my entire test suite, but I know that there is one test that was broken between here and here. So it's gonna screw up kind of, it's not what I'm looking for, but I know it's gonna kind of break it, and I know that those 3 commits are gonna be marked bad because of this other broken test that is unrelated to what I'm trying to find. I can git bisect skip, and I can give it a range. So I can say this one to this one I want to skip, and it doesn't give you any feedback, but it will skip them. Good. Let's say then this one is good, and git bisect bad. Well, anyway, you're not going to kind of be able to see what it's doing, but that's how you give it a range, and that's how it skips a whole range of commits. But yeah, keep in mind that the larger the range that you skip, obviously the less nauwkeurig, the less exact your binary search is going to be. It's nice to have a Dutch-speaking person in the room, so that when when I forget a word, I can just do that. Okay, so of course, wait. Oh yeah, this is the caveat illustrated. Yes, go ahead.
How can you do skips from a script?
How can you do skips from a script? That's an excellent question, which of course I've prepared for. You can do a skip from a script. That sounds so weird, skip from a script. That's like a tongue twister. So remember I was telling you about like an extra special exit code? Okay, so that extra special exit code is 125, and you can use that as a skip exit code. So let's say this is, okay, so I'm doing the same thing as before. I have this README script that I was doing before, same repo. But let's say there's some problem. So now I'm just taking a random number, and there's just a chance that it's going to be untestable. But normally you would maybe say like, you try to compile something, and if it fails, then exit with exit code 125. But just for illustration's sake, I've done this number. So it's either going to be untestable and skips it and show you that it's actually skipping it, or it's going to run this this readme file exist script that we saw before. So you can also, by the way, already give your good and bad commits initially. So if you want to do that, you can start with the bad commits. So in this case, it's going to be my head. And then I'm going to say the good commit was 25 commits ago. Okay, so we've marked our good and bad points. And then we're going to run the thing that, so just like before, get bisect run. But then instead of this readme one, it's going to be, I can't remember what it's called. It's going to be skip.sh. Yes, that makes sense. So you'll see that it's doing the file exists, blah, blah, blah. But there's been a few that were untestable. So it's skipped those. And then it's done the other ones. And it shows us the first bad commit. It would be nice to be able to show you what it says if if the first bad commit was adjacent to like a skipped one, because I think it gives you, I mean, we can run it forever and ever, I suppose, but I'm fairly sure it gives you a slightly different output. It'll say something like, couldn't exactly tell you which one it was or something or other. So that's a really good way to kind of circumvent issues like that. You can also run anything else with the script. So for instance, if you do know that you need different dependencies 25 commits ago or 100 commits ago, which is very, very common, you can also make it run composer install first at the start of your script every time it checks out a commit. So that's something that I would definitely advise you to do, to have a little composer script that you can run with every bisect, because that's definitely a very common thing. You can also, like, if you're, yes?
Yes,
Sorry?
I don't know if I've been unlucky, but when I've tried to do this, there always seems to be a database migration between the good point and the bad point. So is there a good way of dealing with that?
Migrations are a tough one, but then I suppose you would have to roll, with your script, you'd have to then roll back migrations. It kind of depends on what kind of migrations you use, but yeah, then I suppose you'd be kind of hard to know how far to roll it back. That's an interesting question. So the question was, sorry. I didn't repeat the question. So the question was, okay, they might be unlucky because anytime they've tried to do this, there is like a database migration issue somewhere in the commits, which makes sense because like migrations are, run subsequently in order. And if you want to go back, you have to roll back your migrations to that point. So you are going to have that issue. And I don't really have an answer to that. You could try and script it, but I also don't know off the top of my head an easy way to script that. Yeah, that's something to think about.
Maybe just destroy the database and just run all the migrations up to that point, so you don't
Yeah,
have to roll back.
yeah, that's actually a much better point. Thank you. You're much more awake than I am. Yeah, that is the answer, folks. The answer is, for the people at home, the answer is just destroy the database and run the migrations again instead of having to figure out how far to roll back. That's much. You burninate the database. That's it. Much smarter. Yes, another question?
Does the git bisect pass anything to the script? For example, for the script to know if it's gone to the future or to the past?
Ooh, kind of like parameters that, like query parameters or something for.
Like some kind of knowledge what the previous commit was or something like that.
I don't think so. I don't think that exists. That's very interesting, though. That would be kind of cool. I also can't immediately. Did you have a specific use case in mind?
I just want to know if I should run the migrations or roll back. So.
Okay. All right. Yeah, sorry. So the question was, does bisect, I'm so bad at this, does bisect pass any parameters to kind of like the next checkout so that the script can know like what the last checkout was or what, yeah. So as far as I know, that doesn't exist. I suppose you can kind of like hack something like that with like a temporary file or something where you store that and parse it, but then maybe you're making your life very difficult. But that's another very interesting question, yeah. Okay, does that answer your question?
Yeah, sort of.
Yeah, I mean, I suppose the answer is just no. So,
I guess when it's bisecting, you could execute like a git command, like on which hash am I now, and then you know.
yeah, yeah. I've also thought before about, I don't know if people are familiar with Git work tree, but I've also thought about starting a work tree. So a Git work tree is basically a command where you can store your entire current work tree and just put it on your file system somewhere so you can CD into it later. Yes, it's kind of wild, but it's really cool because it kind of you don't have to stash or commit anything, and you can just move around, which is quite cool. So you could do something like that as well. You could just kind of have the script go check out a new work tree and name it the commit ID or something. I don't know, something like that. Yeah, you can get really creative with things like this, I feel like. So yeah. Okay, so some more examples. You can also apply patches. So let's say this one is taken straight from the documentation, just ripped off. But for instance, the documentation gives this example of like sometimes you might want to set a debug flag or something like that on so you can apply a patch on every commit and then clean that patch up again when you go to the next thing. So that's also really interesting. Yeah. So those are some I like how creative we're all getting. You can get so creative with this. But yeah, in conclusion, I would still give you the advice that if you can, keep the scope small. Like, don't run your entire suite, don't run integration tests, don't, do any of that stuff if you don't have to. If you don't want to deal with database migrations and stuff like that. Keep your commits atomic. This QR code will take you to an article about atomic commits and why I love them. They're basically like the foundation of how I do Git, and it just makes your life easier in lots of different ways. It makes Git features, especially bisect, I think, much more useful. So you can really start, if you integrate that into your workflow, you can really start using Git much more optimally, and in my opinion, much more like it was designed, like and intentionally. But that being said, so yeah, atomic commits are really good also in cases where, like the thing that we demoed before, where you have a really small commit and you're looking for a regression. If your commit is really, really large, you may have found the commit, but you still haven't found so it still makes the debugging kind of a pain. So keep your commits small. So if you can't keep the scope small, if you can't work with atomic commits and like stable commits everywhere, then write a bisect script if you have to, and you'll still be golden. So thank you. I would love to see if there's more questions.
Great talk, really interesting tool.
Thank you.
What directory does the script run? Is it the directory that you're currently in when you run git bisect, or is it the root of the repository?
You mean like, yeah, so if it's looking for the file, is it looking for the current directory, or is it, yeah. So yeah, so the script is outside of the repository, but if you run it from inside the repository, it's going to look for the file inside the repository, so you don't have to screw around with paths and things like that.
Right, okay, thank you.
Anything else? I'm so happy that you all, an entire talk about a single feature. I wasn't sure how it would go, but I'm happy that people are into it. I think there's a question here.
Yeah, it's kind of related. So
Wait, you're getting a mic. Yeah. Oh.
when you were doing the rebase and you were changing the commit hashes, like I've had cases where there's a repo and it's just 100 commits that say like do the thing, right?
Yeah.
And then if I've rewritten all the hashes and then it's one of the do the things that's broken, like how do I trace it back? Like when I do a rebase, how do I know what the original hash was?
You don't.
Right.
You don't. Yeah, you don't. What you can do, if the rebase was recent, you can reflog. You can also, if you're scared of that, so, okay, this is all. It's becoming a different Git talk. But yeah, there is ways around that. You can also use work trees to kind of like store your state somewhere else and you don't have to worry about it. But reflog is kind of like a commit log, but with all the steps that you've recently taken. So you can kind of do a hard reset back to before you started the rebase, and then you'll get your state from before the rebase back. So it's all not as permanent and scary as people often think it is. So knowing that will make you feel a lot more comfortable screwing around with your history. Yeah. I think we're good. Thanks a lot.